Dealing with a dangerous situation. Attention! Phosphorus pentoxide, phosphoric acid, sulfuric acid and sulfur trioxide can cause severe chemical burns on the skin and eyes. Sulfur trioxide can also cause irritation of the respiratory tract and reacts violently with water. In the experiment, the setup was made of a distillation apparatus with a dripping funnel. The flask contained phosphorus pentoxide and the dripping funnel contained sulfuric acid. Some might have already noticed that there is a problem. Unfortunately, I noticed it too late. The oil bath was heated up to 80 degrees C to heat the phosphorus pentoxide. Then the sulfuric acid was carefully added, and this is where I noticed the problem. The flask had a crack at this point which could easily expand when it's heated. Another problem was that there was now a mixture of phosphorus pentoxide, polyphosphoric acid and sulfur trioxide in the flask. All of the compounds react very exothermic with water. Sulfur trioxide can even explode on contact with water and is a strong oxidizer. Sulfur trioxide forms a dense fog in air. The majority of the phosphorus pentoxide could be removed easily. The residue was a tough mass made of polyphosphoric acid and traces of sulfur trioxide. As a test, a part of the mass was added to a large amount of water to find out how violently it reacts with water. It took quite a while until a reaction took place which could unfortunately only be heard here. Another sample reacted slowly, which is why I decided to try treating the mass with water. The flask was placed in a plastic container to collect the acid if the flask breaks. In addition to that, it would have been a shatter protection in the worst case scenario. This method is for sure not the best one, but the cheapest. A correct solution might probably have been to add sulfuric or phosphoric acid until everything became liquid and then add the liquid mixture to ice-cold water or even directly to ice. Corresponding to the first test, the reaction was not too violent and was over within a few minutes. The temperature of the solution was only 77 degrees C, while I was awaiting it to be way above 100 degrees C. The phosphorus pentoxide was also treated with water. This video should not be seen as a kind of manual, but it should show that a synthesis has to be stopped immediately in such a situation, and that small tests might help to estimate how violent a reaction might be. This was dealing with a dangerous situation. I hope you enjoyed. Please rate and comment.